A lot of students told me that they had trouble with the fifth lecture question from last week. And so I wanted to create a video to describe how this problem could be solved. So you were asked to show that the identity sine of 2 theta divided by sine theta minus cosine of 2 theta divided by cosine of theta is equal to secant of theta. Now in general, it's best to verify trigonometric identities by first writing just one side of the equation. And you want to choose the more complicated side, which in this case is certainly the left-hand side. So I would start by just writing the left-hand side down. And the goal in solving this problem is going to be to simplify this expression that you have on the left so that it turns into just secant of theta. So you could look at these identity problems as just simplifying problems where you simplify an expression, and you're given the answer. We know that this thing needs to simplify to just secant of theta. So you can kind of cover up the secant of theta and just think of this as where I'm simplifying, and in fact I know what the answer is supposed to be, so I just have to clearly show all the steps. So to do this, you're going to need the double angle formulas for sine and for cosine. Sine of 2 theta, there's only one option there. That's equal to 2 sine theta cosine theta. Now, cosine of 2 theta, you actually have three options there. Cosine of 2 theta, the way I think of it, there's this first fundamental, just cosine squared minus sine squared. But using a substitution, that can also be written as 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. And you have to choose the option that best suits the problem. So sometimes that can make that tricky having options there. But let me start with just that sine of 2 theta. So there's only one option for sine of 2 theta. It's 2 sine theta cosine theta. And that's over sine theta. And so right now I notice that I can cancel a common factor of sine there. Now over here, this is where I have the three options for the numerator. For that cosine of 2 theta, I have to choose which option best suits the problem. I'm hoping that things will cancel, and here, just kind of leaving that numerator blank for now. I notice that when I cancel in that first fraction, I'm going to have just cosine of 2 theta there. And I want to simplify this to secant, which is the reciprocal of cosine. So I like to have as many cosines involved, it looks like, as possible, so that hopefully I can make this cosine go away and end up with a 1 over cosine, which will give me secant. So I'm going to choose this option. Now, you can make this work. You can get a solution using any of those three options I listed for cosine of 2 theta. So try not to freeze up and then just not do anything. The motto of these sections on identities is do something. Even if what you do might lead you down the longer path, or it might even be a dead end, but you still learn something from that. Okay, so since I have two parts to that numerator there, I'm going to break it up as two separate fractions. So 2 cosine squared as its own fraction divided by cosine of theta minus 1 over cosine of theta. The one thing you have to be careful of when you break this up into two fractions is the negative applies to the entire fraction. So when I break this into two parts, the negative applies to both parts. So I'm going to distribute the negative on the next step. I also want to cancel a common factor of cosine here. So now this is 2 cosine theta. Distribute the negative, so it's minus 2 cosine to the first after I cancel that factor of cosine from the top and bottom. And then the negative here times the negative here, when I distribute, that'll be a plus. Oops. Plus 1 over cosine theta. And now 2 cosine theta minus 2 cosine theta, those are gone. I'm left with 1 over cosine theta, which is equal to secant theta. So I've arrived at the right-hand side, and so I've proven this identity.